Hey guys, really sorry I couldn't be in today. Um, Instead of being in, I've pre-recorded this video, as you can see. And from the looks of things, we're going to have to go by pre-recorded videos for a lot of our upcoming lessons. So this will be a taste of what your your science lessons are going to look like, and all your lessons are going to look like from this point forward. This video was very impromptu. This was quite rushed. So yeah, as you can see right now, you've got the full view of my bedroom. So enjoy that while you've got it in front of you. But yeah, sorry I couldn't be here. I wanted to be here to introduce what we're going to be covering as our next topic in Year 9 Science, and that is electricity. If you haven't got your these books with you, get them out. You guys should already all have these. I've given them all out. So yeah, get out these PowerPoint notes, and I'm going to start to take you guys through our topic of electricity. In electricity, in this topic, we're going to cover a lot of things. We're going to cover types of electricity, so static electricity and current electricity. We're also going to cover what volts mean, what current means, what resistance means. This is really one of the best topics in Year 9 Science, because we're also going to be learning how to wire electronics. And an activity that's coming up, or might come up, at this point, look, I don't really know, but an activity that's been done in the past for Year 9 Science is Year 9s have had the opportunity to wire their own electronics and build their own electronic game, which is really a lot of fun, and it's almost the highlight of Year 9 Science for all students. So hopefully I don't know what's going to happen at this point, but hopefully we're going to learn enough to steer us towards that direction. So yeah, like I said, get your PowerPoint notes out, and we'll carry on with this lesson. So as you can see, we're starting with simple circuits. So the first question that needs to be asked is, what is electricity? Electricity is a form of energy. So we got multiple different types of energy. We've got kinetic energy, we got light energy. Electricity is another form of energy. The thing that defines electricity is it's the movement of electrons. All right. So electricity can be converted into those other types of energy, like kinetic energy, sound energy. So just hearing sound, that's a type of energy. Heat is a type of energy that's known as thermal energy. If that's going over your head at the moment, don't worry, we can talk more about types of energy later. But what we're focusing on now is electricity as the movement of electrons. So what you should be seeing here should be revision. All right, so we have an atom in front of us. You guys should have covered this last year. Atoms are made of three main particles. We've got protons, neutrons, and electrons. Protons and electrons are the charged particles. Protons are positively charged, and electrons are negatively charged. Electrons are tiny particles, and they're the ones that surround the nucleus of the atom. The thing with electrons is that electrons can be removed from an atom. If you remove an electron, that changes that changes the atom's charge. So I'm going to move on to the next slide here to further explain this. So electrons can be knocked out of an atom's orbit. If an atom loses an electron, then it becomes positively charged because it has more protons than electrons. If it gains an electron, it's going to be negatively charged because it's got more electrons than protons. So again, this is revision from last year, but you should remember, if it's got more protons, that means it's more positive. If it's got more electrons, that means it's more negative. All right. Now we're also this is defining terminology here. When we have an atom that's got more electrons or less electrons, that's charged in some way, it's no longer called an atom. It's supposed to be called an ion. All right. So technically, the technical name for an atom that's charged is an ion. But yeah, because electrons are able to be knocked out of knocked out from atoms, we've got electrons that are actually flying around us and moving around us all the time. We've got electrical energy everywhere around us. We don't have a lot of electrical energy, but we do have electrical energy around us. All right. So that's if we find scenarios where we gather a whole lot of electrons and move them all at the same time, that's where we start getting a lot of electrical energy. That's when we start getting electricity. So there are two types of electricity. All right. The first type is static electricity. Static electricity is static electricity is the movement of electrons from one surface to another. Static electricity, you're probably very familiar with the term static electricity when you say get a balloon and you rub it on your head. I'm sure you've all heard the term static electricity before, but perhaps you don't quite know what static electricity actually means. Say, for example, so I've got this balloon here. If I was to rub it on my head, what I'm actually doing is I'm actually moving electrons from one surface to another. That's what static electricity is, remember. Static electricity is the movement of electrons from one surface to another, just like we got in this diagram. So if I move this balloon on my head, and then I start to raise it, hang on, let me just adjust it so you can see. So if I move this balloon and start to raise it, what's happened is the electrons from my hair have actually moved onto the balloon. That's the movement of electrons from one surface to another. Electrons have moved from my hair onto the balloon. This has meant that this balloon has more electrons than normal. My hair has less electrons than normal. My hair is positively charged because it's got less electrons. The balloon is negatively charged because it's got more electrons. So if I do that again, my hair's slightly rising. And that's because my hair is positively charged, positives are attracted to negatives, opposites attract. So that's why you see hair rise. That's why you see things like this occur in static electricity. The electrons are trying to move from one surface to another, and the positive surface is now attracted to a negative surface. All right. But the thing with static electricity is it's only very temporary. The electrons end up jumping back onto my hair, and my hair ends up flattening down, and that's that for static electricity. It's very temporary. So we see in this diagram, we got electrons moving from one surface to the other. That makes this surface positively charged and this surface negatively charged, and then they return back to normal. Sometimes when they return to normal, that can release a lot of energy. It didn't in the case with the balloon. There wasn't much energy went in the return. But sometimes there's a lot of energy, and you can see a spark. That is how lightning works. Lightning is a case of static electricity. And you're seeing a spark because that's electrons that have gone from the cloud to the ground and then returning back. And as they return back, there's a big spark. So that's the first type of electricity. We're going to talk a little bit more about static electricity and flesh it out a little bit more later. But what we're mostly going to focus on in this topic is the second type of electricity, and that's current electricity. Current electricity is the movement of electrons through a circuit. All right? Current electricity only works with a circuit. So here's an example of a circuit. We've got a battery and a light bulb. So I've got some examples here in front of me. Most people think if I take a light bulb and a wire and a battery and I just connect them up like that, it would light up the light bulb. It's not in this case. Even if I wire up the correct way, it's not in this case because this battery hasn't got enough voltage to power this light bulb. We'll talk about what that means later. This is the best I could find on short notes. But most people think if you just connect a battery to something else with one wire, that's all you need. But that's not actually how a circuit works, because a circuit means circle. You need a flow. You need a circuit for the electrons to flow. Current electricity only works when you've got a circuit. So instead of one wire, I get two wires. I get two wires. Each end of the wire connects onto the light bulb on this end, and each end of the wires connect onto the battery on this end. I'm dropping them all over the place here. So battery has two wires, light bulb has two wires. That's now a complete circuit. And if this was wired up the correct way, we would actually see the light bulb light up, because I've now created a circuit which electrons can move through. All right. Electrons cannot move through a one-way connection. That's not how current electricity works. So, yeah, here, the main things that, move on to the next slide. The main things a circuit needs is an energy source, so that's like the battery, an energy user, that's like a light bulb, and conductors. That's like a wire. A conductor means anything that can conduct electricity. So anything that electrons can pass through. So if something conducts electricity well, electrons can pass through it well. So yeah, simple circuits need at least these three things. What we're going to end up getting to a point at with this course is you're going to learn how to actually draw diagrams of circuits. And this is actually really useful information in the real world, because if you end up going on to become an electrician, this is essential information. You want to know how to simply draw an electrical circuit to tell someone else. And it's also good information to know if, say, you're building a house plan, or something, if you're building a house or something like that, and you need to see the wiring within a house. So this is actually pretty important information. So circuits are drawn with universal symbols. We'll get to a point where you guys should understand what each of these symbols are, and they're pretty simple. So these are light globes. This is a wire is just a straight line. We've got switches here like this, and ammeters and voltmeters. We'll talk about what they are later. Batteries look like this, and yeah, resistors look like that. We'll talk about what they are later. So here I've got an example of a torch. A torch is a really, really basic electric item. All it has is a light globe, a battery, and a switch. A switch is something that connects, turns on and off a circuit. It connects a circuit and disconnects it. So the switch, if the circuit's disconnected, that means it's no longer a circuit and electrons can't keep running through. But the switch can help reconnect the circuit so that electrons can run through again. But as you can see, we got two really simplified versions of a torch here. But the most simple version of the torch is the one on the end. And this is how circuit diagrams look. So that's where I'm going to leave it today. The main things I want you guys to cover and learn about for this lesson are three main things. Firstly, the knowledge of what electricity is. Electricity is charge. It's the movement of electrons. Second thing is know the two different types of electricity. We've got static electricity and current electricity. And third thing is what is a circuit and what are the main components of a circuit. All right. So I've got some style questions that I'm going to leave for you guys. It'll all be straightforward. But yeah, thanks for listening, and we'll see how we go with science in the future. Okay.